So we're looking here at a precipitation type problem. Now the idea here is that we're going to start off. I'm going to show you a couple of pictures just to give you a little bit of context as to what's going on. So we've got this solution of A3B2. So every A3B2 will break up into 3 A's and 2 B's. That's going to be important. And we're going to add that to a solution of CD4. So that's going to be C and 4 D's. And then it's going to form a precipitate that has the formula AD2, which is going to be from an A combining with 2 D's. Now the fact this creates 4 D's and this has 3 A's isn't going to affect what's going on over here. What we're going to do is we're going to find the individual concentration of A over here in this initial solution, and we're going to find the concentration of D over here in this solution. We're going to take into account two things. We're going to take into account the fact that each A3B2 creates 3 A's, each CD4 creates 4 D's. We're also going to take into account what happens when we dilute them, because when we add this solution to this solution, we get a bigger solution over here. See, it's 160 and 130. That's the total solution volume over here. So it's 160 mils, that's 130, and that's 290 over here. Alright, so let's take a look at how we go about doing this. So we start off with the reactions. So we know that A3B2 will give 3 A's and 2 B's. We know that CD4 will give C plus 4D. And for the precipitate, we know that the reaction is going to look like this. AD2 solid is equal to A plus 2D. And that's going to be aqueous. Those are going to be aqueous solutions. So we're only interested here in the A and the D. We're not interested in the C and B at all because they're not part of the precipitation reaction. Alright, so what we're going to do here is figure out the concentration of A now in the A3B2 solution. And here's how we'll go about that. We'll go 0.00380, that's the initial concentration of A3B2. And each of those will form 3 moles of A for every 1 mole of A3B2. Now this is going to get us to 0.0114 molar of A. So that's in the initial solution there. And we're just taking into account the fact that 3 moles of A3B2 forms 3 moles of A for every 1 mole of A3B2. The next thing we've got to do is figure out what happens with the dilution, and for that we use the dilution formula C1V1 equals C2V2, and that's going to be, now we're just going to plug in those values. We've got 0.0114 molar of A, and it's important here we use this concentration here, not the initial concentration, because that's what's in the actual solution. And the amount we have is 130.00 mils. And then we want to figure out the concentration once we get it into 290.00 mils. Now the 290 is the sum of 160 and 130, 130.00, 160.00. And the value of C2 then is going to be it's going to be 0.00511 molar. and that's the concentration. That's the concentration of A. Concentration of A where? Well, in this solution up here. That's where that comes from. Alright, so what I'm going to do is I'm going to erase some of this, and I'll show you what happens with the D. So with the D, we're going to look for the D now in the CD4 solution. And the way we'll get that is we will do 0.00315 molar, that's CD4, and that's from up here, times, and we're going to get 4 moles of D for every 1 mole of C, D4, which is going to come out to be 0.0126 molar. So that is the concentration of D in this solution over here. Now we need to work on the concentration once it's diluted. So what we do is we take the 0.0126 molar. Again, we take this value here, and we multiply it by the volume, which is 160.00 mils. That's the initial volume. And we're looking for the concentration once it gets to 290.00 mils when it's diluted up here. So to get that, we would solve for it, and C2 comes out to be 0.00695 molar of the D. And that's again in this solution right here. Alright, so now we've got those, we can go ahead and calculate our Q value. So I will rewrite those. So the values we calculated again, the values we calculated again were for A, and this is in the diluted solution over here, is going to be 0.005111 molar of EA, and for D, what we calculated was 0.00695. So this is in the diluted solution. Now we can figure out for QSP, which is going to be from over here, is going to be A D to the power of 2, and the A is going to be 0.00511, and the D is going to be 0.00695, and that's going to be squared, and that's going to give us a value of 2.47 times 10 to the negative 6. Now that's the QSP value, but what we're interested in is PQSP, which is the negative log of that. So PQSP, negative log of the QSP, which is going to be 5.607. So just put that in your calculator, hit the log button. The number of decimal places here will match the number of significant figures in the QSP number that we've got over here.